Okay, 9.1 is all about sequences. Well, the whole chapter is about sequences. It's a pretty important topic. It comes up on the SAT. I was just looking through the ACE Math Review, and it's on the ACE Math Review. See it in college algebra, all that good stuff. So this isn't like a topic that you just see once and it goes away. Okay. So here's one way you could have written the definition. Sequence is an ordered list of numbers. What's that? Just a list of numbers. Each number in the sequence is called a term. Pretty straightforward. Okay, we're going to do 3 problems as examples, and then you're going to do your assignment. Your first set of directions is to write the first 6 terms in a sequence. This is the rule for the sequence. It says a sub n equals 1/2 n minus 3. This is just a linear equation. If I was to write this as a linear equation, it would be y equals 1/2 x minus 3, which is just like y equals mx plus b. Okay, so this is really not too different from this. A sub n is indicative of a sequence instead of a full equation. The main difference is this is a list of numbers. Like when I look at this graph, it's just points. You don't connect the points with a line and show arrows that go both ways forever. This is like a discontinuous list of numbers, whereas an equation like follows through, it goes on forever. So the same thing you know, the patterns you know about this apply here. So your first task will be to write the first 6 terms in this sequence. So this is how you write it. Well, I'll zoom out for a minute. The first term you call a little 1, the second term a little 2, third term a little 3, fourth term, fifth term, and sixth term. So instead of y equals, it's a n, and the n is the order in which the numbers go. So let's do the first term. All I'm going to do is write the equation, and I'm going to plug in 1 for n. Then you can grab your calculator. It is a fraction. Feel free to do it all in your calculator. 1/2 times 1 minus 3. And in the second one, I do the same thing. I just plug 2 in for n. 1/2 times 2 minus 3. And then I do 1/2 times 3 minus 3. 1/2 times 4 minus 3. And it's going to feel a little bit like busy work, but I assure you it is not busy work. The more you plug in and find the list, the more capable you'll be at finding patterns later on. So later in the chapter, we're just given a list of numbers and you have to figure out the pattern. So this plugging in is really important. 1/2 minus 3, I get a common denominator. 3 is 6 over 2, negative 5 over 2. So the way I would write this is a sub 1 equals negative 5 over 2. And so this means the first term is negative 2.5. First term is that. 1/2 times 2 is 1. Minus 3 is negative 2. A little 2 is negative 2. Let's do it again. 1/2 times 3 is 3 over 2 minus 3. Need a common denominator. Negative 3 over 2. So the third term is negative 3 over 2. I'm going to pause now and let you finish the rest. And then I'm going to challenge you. Can you find a pattern in the numbers? This depends which way you're looking. If you're looking down, it's actually going up. Okay, next one. 1/2 times 4 is 2. And 2 minus 3 is -1. So the fourth term is -1. One half times 5 minus 3, 5/2, minus 6/2 is -1/2. And then the last one, 1/2 times 6 minus 3, 3 minus 3 is 0. That's it. Plug in 1, 2, 3, 4, 5, 6, get your numbers, make your list. That's it. So this written as a sequence would be -5/2, comma, -2, comma, -3/2, comma, -1, -1/2, and 0. This is the sequence, and the rule or the equation for the sequence is what we were plugging into. So the most difficult part of the chapter is when they just give you the list and you have to write the rule. And that's what's supposed to be done on Friday. So we'll see how that goes. So like Peyton just said, this is actually going up 1/2, up, you could think about it as up 0.5, up 0.5, up 0.5, and up 0.5. So that's the pattern, is it's adding 0.5 every time. Adding and subtracting is a linear relationship. So that up 1/2 is the slope. What we know of in y equals mx plus b is the slope. So adding and subtracting means you're writing an equation that looks like y equals mx plus b. So that I knew that pattern was going to show 1/2 because I saw the 1/2 there. All right, let's do another one. So the first type of pattern you might see, if it's addition or subtraction, that's called linear. Add or subtract is called linear. This next one is a different type of equation. The equation says write the first 6 terms. So this is like y equals 2 to the x minus 1. This is an equation, and that's a rule for a sequence. Different notation. What would this one be called? It's not called linear. What type of an equation is it? Exponential. This is an exponential equation. So this will show a whole different type of pattern. So there's lots of different equations and patterns wrapped up into this chapter. The first section has the most variety. The next two are very straightforward. So all right, let's do the first term. So a little one, this is 2 to the first power minus 1. I'm taking the little number in the n spot and plugging it in for n. So this is 2 to the 0 power, which is 1. So in this one, the first term is 1. Box it. The second term, 2 to the 2 minus 1, that's 2 to the first. The second term is 2. Now I'm going to wait and let you plug in and see the pattern emerge. See if you can figure out the pattern. Don't put after the first example. First example is the easiest one. Don't put. Daniela, have you found the pattern? What do I get when I plug in 3? It's an exponent. No, not quadratic. It's a half of you. It's like a You figure out what you're doing there, Danielle? You were multiplying the exponent. So to the 4th is 16. And now 4 to the 5th is 32. So here's our sequence. It's 1, comma 2, comma 4, comma 8, comma 16, comma 32. This is the actual sequence. Oh, I should have written it down better. 2, 1. So I would say that the third term is 4. And the fourth term is 8. And the fifth term is 6 term. And the sixth term is 32. So, what's the pattern? Yes. Times 2 every time. Times 2 every time. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. This is indicative of an exponential pattern. Okay? So if you multiply or divide, that means your exponent is up high. All right? If it's addition or subtraction, you have a slope and a linear equation y equals mx plus b. But if your pattern shows multiplication, then your variable, your x or your n value will be in the exponent spot. Okay, so that's an exponential pattern. Yeah, and if we graphed it, it would be like a ramp. All right, last example. This is it. It just says graph a sequence. It says make a graph. Just shows a list of numbers with a comma. It says make a whole graph. So, and I do encourage you to look at the book and read the examples, but I'll give you the details here. If you're asked to graph a sequence, you have to know, it goes in successive order. So this is the first term in the sequence, and then the 2 is the second term. The 3 is the third term. I'm sorry, 9 over 2 is the third term, and 8 is the fourth term, right? So this is a sub 1 equals 1/2. A sub 2 equals 2. A sub 3 equals 9 over 2. And A sub 4 equals 8. Now these are ordered pairs. These are points that we are not going to connect. So the point would be 1 comma 1/2, 2 comma 2, 3 comma 9 over 2, and 4 comma 8. This is x and this is y. X, y, x, y, x, y. So the number it goes in the list is like the x value, and the actual values in the list are like the y values. The thing that makes the difference between a sequence and an equation is that you do not connect the points in a sequence. It's just going to be dot, 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 dot. It's called discontinuous. The other main difference is that we don't call it x and y. That's kind of a big deal. Instead, the horizontal axis is labeled n, and the vertical axis is labeled a sub n. So this is 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 7, 8, 9, 10. So we have 1, 1/2, 2, 2, 3, 4.5, and 4, 8. And it's so hard. I really want to connect my points. I really have to resist the urge. They're just points. Don't connect them. So this is a whole third entirely different pattern here. What's the pattern happening here? Pretty tough. It goes from 1/2 to 2 to 9/2 to 8. What is this pattern? This is a weird one. When I see how they're going up by, like this one, I can see it went up 1/2. When I look at this one, it goes up 1.5 and then 2.5. So that's not consistent. That means it's not linear. It would have to be the same number. What I do notice, and I just want to really give you a preview of this, a heads up, is that this is going up 1, and this is going up 1. These are called constant second differences. And that means that this is a quadratic. Quadratic patterns have constant second differences. So I'm thinking the rule for this is an equals n squared. But 1 squared is 1, and it says 1/2. 2 squared is 4, and it says 2. 3 squared is 9, but it says 9/2. And 4 squared is 16, but it says 8. So it's not so simple as n squared. So it's 1/2 n squared. So the hardest thing of doing this whole chapter is they'll give you a list of numbers, and you have to identify the pattern and figure out the equation for it. That would be the most difficult thing. Now, that's not today's assignment. Today's assignment is just plugging in and making the list of 6 things. Okay? So it's 2 through 10 even. You have to show work. It might really feel like busy work, you guys, but it is not. Plugging in and seeing the pattern emerge is really important for you to be able to recognize patterns in the future. So please don't feel like showing your work is busy work. It's actually a really important progression.